Okay, let's resume on the rotary or angular displacements transducer. So basically, we will look into few different optical encoders. We look into resolver and synchro, which are a part of the rotary displacements transducer. So optical encoder basically developed in the middle of 1940s, and it has a advantage of being having a digital output, low cost, reliable and immune to noise. There are different types of encoder, incremental and absolute, which will be discussed in this part. So, so it's we have a simple optical encoder. So have a set of disk. So the disk have a pattern where some part of it is removed and or no some part of it's paint or cover with dark coating. So basically light will not be reflected on that surface. So it has a stripe or checkered pattern on the disk. So basically the this have a light and dark wedges, and the output will be in digital. So in this case, the pattern or the dark or light wedges are made equivalent distance between them. So the velocity can be if this is connected to a moving shaft, and the disc basically will move in between the optical detector. Basically, it will produce an output pulse, and the velocity of the pulse, which how many H in per period can be used to determine the velocity of the uh, uh, turning shaft. So the limitation of this encoder, it cannot determine the which direction the shaft turn. So whether it is moving on clockwise or counterclockwise, it will give a same pattern, but it can be used to detect the velocity. So one way to overcome or to get the answer or to detect the the position of or the direction of the turning or the movement is by using a quadrature encoding, whereas using a two detector side by side. So basically the detector A and B will have an output, have a slight phase shift in between them. So for example, in the first case, when the this is moving or spinning counter or counterclockwise. So the system, okay, will when the A output is rising, so the system will check the output of B. So when the output B is low, when the output A is rising or increasing from 0 to high, and at the same time the output B is low, so the system know that this is moving clockwise. And on the other direction, counterclockwise, when the system detect the rising edge of output A, so it will check in the same time will check the output of counter output of sensor B or optical detector B. So if the output is high, so the system know that this is moving counterclockwise. Okay, so the quadrature encoding used two sensors and each side by side, so having a 90-degree out of phase, used to compare sensor output or especially the directions. And then now we have an incremental encoder. So it is easier to integrate than absolute encoder. For example, a single channel tachometer encoder uses square pulse to each sub revolution, and the trade-off is the resolution versus the rate. Okay, so means that the higher the rate or the smaller the resolution, the rate of detection, okay, also affected. So the basic construction of optical rotary incremental encoder, you have at least 5 components. LED as a light source, okay, and rotating code disk, okay, this with encoded pattern, okay, and a stationary mask, photo detector, and amplifying or squaring electronic. So basically the purpose of the amplifying or squaring electronic to make sure the output is nicely triangular, okay, in a form of pulses. So as the code disk rotate, okay, the code disk rotate in front of the stationary mask, it shutter light from the LED, okay, and the light that pass through the mask is received by the detector, which produce pulses in the form of close to sine wave. So basically, the encoder electronic convert the sine wave into square signal. So it basically improve the output into square signals. Okay, so basic operation of optical rotary incremental encoder. It contain a fixed number of equally spaced, okay, opaque lines that produce a corresponding number of pulse per revolution. Each line count require a unique code disk. The position and spacing of the line on the disk require a high degree of precision. So physical limitations determine the maximum number of lines that can be created on the code disk on a given size So the size of the uh, uh, code or the pattern, uh, it has a limitation. So you cannot make it too small or too fine. Otherwise, the detection will not be as accurate as we intended. So the incremental encoders, okay, the advantage is low cost as compared to absolute encoder, simple construction, structure, simple operation principle, and it has a digital signal output that can be easily saved in a computer. So that incremental encoder. Uh, the disadvantage of incremental encoder is that the faults in generating pulses caused by noise, which affect the accuracy of the encoders. And also it cannot tell the direction of the rotation, movement of the shaft. So this application of incremental encoders you in motor drive control to provide the measured output. Okay, to measure output or basically measure output the speed of the rotor or motor, okay, and convert into the measured output in a form of digital or electrical signals. And others also in copy machine is you use a feedback to synchronize position of the various motion inside of the copier, including document feed, paper feed, and collating. So that's the application of the incremental encoder in the copying machine and also in elevator. Uh, so it is used uh, to provide important positioning data relative to the rate of speed or velocity of the elevator as it moves from floor to floor. Okay. And we have an absolute encoder because it has a much more integrate design, the absolute encoder. It is for slower rotational application and also infrequent rotation like steering angle. I mean that like driver when you used to detect the movement of the steering of a car. So usually the movement is infrequent or it's not happening like rapidly uh, or in a high velocity. So this advantages is not tolerant to power interruption and operational limitation with the temperature. Okay, so absolute encoder give an parallel output in a gray code, which allow one bit change between adjacent resolver step and reduce the maximum reading error to one step. Okay. So like for example here we have an encoder with a gray scale, gray code, where the output is only every step of the output only change one bit. Okay, so that's a gray the output in gray code. So advantage is that is to reduce the uh, uh, false in detection. If the let's say multiple bit change or multiple code or output change at one step, so it will have a high tendency to cause a false detection. So a gray code absolute encoder can be used so that to reduce the false detection. So the use of encoder when position data must be retained after lost power. So means that especially in device when there's a total shutdown. So when the power has come back, so the system know the actual current position, and make a strategy to return to the original position or to the default position, like a robotic arm, for instance. So when there is shutdown, the robotic arm will suddenly stop. So when the power is returned or restored, it know the actual position, and then try to create a path of to return to the origin safely. So this can be done by using a pseudo encoder. Okay. This is the basic operation. It has basically a rotating encoder disk. Okay, similar like the incremental encoder. Okay, same construction, but the different pattern of the rotating encoder disk. Okay, this is the advantage. So this non-volatile memory means that it can retain the position of the actual position, okay, without when the power supply is removed, or the power shutdown. Okay, so it is a safety feature, and also it is immune to noise. So because the output is based on coded signal. So like I explained, the best way to have a unique pattern which only change one bit at one between step, like a gray code. The disadvantages is high cost because of the integrated design of the rotating disc, and difficult to produce high accuracy. But that maybe has improved because of the engraving, like the laser design, laser technology that can engrave, okay, very accurate rotating this pattern. Application is in like automatic storage and retrieval system. Okay, where the system have to know the exactly location of the shelf. Okay, must move very precisely to prevent misplace or collision. And also in robotic arm, so the absolute encoder provide, okay, the precise angle at every axis degree of freedom lah. So some robotic arm have 6 degree of freedom or more. So it know the angle of each degree of freedom, and then can move safely. And in valve control also, where we need to precisely control the opening percentage. So the signal the valve controller may send a signal to the motor. Motor, okay, will move according to the feedback output from the encoder. These are the encoder like resistive digital encoder. Made the slit in the optical encoder replaced by conducting material and surround it with dielectric material. So it based on contact. So the digital encoder will give digital readout when they touch the conductor and then determine the displacement. So this is based on contact resistive encoder. And we have other encoder like rotary variable diffraction transformer. This is based on the change of variation of change of magnetic flux due to the movement of the rotary ferromagnetic core. So basically the output is linearly proportional to the angular displacement. Okay. And it works on AC level. So the RBDT application is used for flight control, flap actuators, fuel control, and basically in the aviation. So it is the advantage is that it is frictionless, okay, non-contact technology, and can be repeatable for many times. So it the lifetime or the shelf life is basically high. And then the other type of encoder is called as a resolver. Okay, I'm going to skip this. This is the application. This is basically have depend on the output of the secondary, two part of the secondary. I think that's I will skip on all that part. Not to going to cover in this session. The rest you can. I mean the one that I don't focus on, that is just for the information that you can check if you require. Right. So I think that's all for today class. So in the next class we will resume on closed loop and open loop. So I will I will finish or check your assignment submission, the first interim, and then give comments, and then we'll try to give the comments, and then you can ready for your final submission and also the presentation. Okay. So I think that's all for today. Okay, thank you very much. Assalamualaikum.
Thank you, Doctor. Waalaikumsalam.